Now, you may not have seen my earlier video, which is an introduction to my CAN bus modules that I've been designing. But if you want to go and look at that video another time, then do feel free. It's a bit long, so I thought I'd give you just a really quick update as to the design iteration 2. So these boards came a couple of days ago, and I've subsequently built them up. And I'd like to talk you through some of the salient features of this latest design. Now, these, for a reminder, these CAN bus controller boards are designed for power distribution and for replacing fuses and relays in cars, and for simplifying wiring and removing all that stuff you get with a single wire to every accessory. You can use CAN bus to control things with computers instead. So the idea is that this is the main controller board. It contains a microprocessor, power supply, and all sorts of other bits and bobs. And then into that you would plug this power distribution module here, or the power controller board, and it will have a special connector on board, an automotive connector on board, and then on the other side, I haven't installed them yet, but on the other side here is where the power controller ICs go, and they've got intelligent fault detection and short circuit detection, overcurrent, undercurrent protection, all those kind of things. Then that board will plug in here. Now, I haven't yet worked out my camera setup, so apologies, but that board will plug in there. And the idea is that these boards at the bottom stay the same regardless of the application, and then just depending on what you want to do, so whether you want to control high current lights and motors and things like that, then you have one of these designed specifically for that purpose. Or if you want to do things like LEDs, you have LED controllers on board, or things for heated seats, or whatever you want. You just have a specific design board to go on top. So let me talk you through some of the cool things I think at least that this has. So I've designed multiple levels of protection into this circuit, so it's nice and robust. I got a bit fed up with blowing things up, so just through clumsiness and accidentally connecting power to digital input on the microcontroller. So I'd like to talk you through some of those things. So here we have a resettable fuse. That's the first line of protection. So if anything on this board draws more than about 500 milliamps, then this resettable fuse will stop that happening and just go open circuit, so it will protect the board. We also have a TVS diode which protects against large surges in power. So if, for example, the alternator suddenly goes doolally and starts shoving out very high voltage, then that will make sure that none of that high voltage goes through. I've also got power protection diodes on the input to the power supply. This whole section down the bottom here, most of this section down the bottom here, is a power supply, and I'll talk to you a bit about that in a minute. I'll just get a bit more light on that. So I've got all that. We've also got all the digital inputs and outputs of the analog. I forgot to say. So this process has analog and digital inputs, and digital outputs as well, and pulse width modulated outputs, and all things like that. What I've designed into this version of the board is these protection diodes here, so that if for any reason any of the pins coming into the microcontroller suddenly has 12 volts going into it, then that will get rid of the excess voltage and won't blow up the main microcontroller. So those are some of the protection features. A couple other features of this board. It's using a Teensy. It's built on the Teensy design, which is just a bit like a much more powerful Arduino. The processor is much faster. It's got many more inputs and outputs, and it's got a lot more memory as well. So it's a much more versatile and powerful processor. So this is the main microcontroller, and then this is the programmer chip on board here. You program it through USB, and you'll notice that I'm using, I don't know if I can turn this up so you can see, And whether it's still in focus or not, but never mind, that's a USB-C, so that means that you can plug the USB in any which way you want. I've got a feature on board here which is this jumper here, so if you want to just program the board and not have it plugged into 12 volts or anything like that, and you're just trying out a few things, then you can bridge that, and instead of using 12 volts and this big power supply here, it'll just use a small regulator there to supply 3.3 volts just for programming the microcontroller. So that's just a useful feature there. We've got the power supply here, so this is a intelligent power supply that supplies 5 volts, 3.3 volts and a standby voltage of about 1.5 volts. That standby voltage will keep the microcontroller ticking over and keep the real-time clock alive, and it can wake the processor can wake up to do tasks on a scheduled or periodic basis. This chip also has another number of other interesting features on it, in that it has a hardware watchdog. So I've designed it so that the microprocessor will signal every, I don't know, I haven't worked out the time period, but every few hundredths of a second or something like that, it will signal to the power supply that it's still alive. And that means that if the processor crashes for any reason, like there's a bug in the code or it gets into some unknown state, then this power supply here can actually reset the microcontroller. And I've actually brought out the reset pin onto this edge connector as well. So for example, if you have a GPS device, which is another thing that could be on the daughter board, if the GPS device crashes, then this power supply chip can reset the whole thing, and it will reset it'll reset the microcontroller, and it'll reset the GPS device as well. So this is a way of just monitoring to make sure that the system hasn't crashed. A couple of other key features on this board. So we've got a CAN bus controller IC here, which will do CAN bus at 500 kilobits per second. No, actually a megabit per second, 1 megabit per second. And also in this new iteration here, I have implemented LIN bus. So this is a LIN bus controller chip as well. LIN bus is used for convenience features in the car, like heated seats, electric windows, what have you, things like that. So I've also put a LIN bus controller on. I'm not sure I'm going to use it immediately, but it's nice to have that option. So that about wraps it up. Just a quick tour over this microcontroller board and its latest iteration. I built it came the other day. The board was populated all from my supplier, all apart from the microcontrollers, the power supply, and these protection diodes here. So it's a fairly simple job just to solder these things on, and I find the more I do it, the more practice I get. Okay, hope that was interesting. See you next time.